Okay, so today we are going to do implicit differentiation. So far we have dealt with equations that were defined explicitly. Something that's defined explicitly is going to either have a y equals or f of x equals at the beginning. It's going to be solved for one variable. So, for example, we may have had something like f of x equals 2x squared minus 5. Or we might have had y equals 1 over the square root of x plus 2. These things are defined explicitly because they are solved for one variable, right? So that f of x or your y, that's your variable that it solves for. Everything else is in terms of x. Just hold on, okay? Just hold on. Now, in this class, we've pretty much only dealt with explicitly defined functions so far. But you have seen some implicitly defined functions in pre-calc. What is it? It doesn't count for spelling, but I see. It's Lee, though. It's supposed to have L. Yeah, it's supposed to be Lee. So, yeah, you're correct. No bathroom passes for spelling errors. Yeah. Close enough, right? Yeah. If I was typing, spell check would have caught that. Okay. I mean, don't you know that all subjects are just separate and never come together at all? So, this is math. We're not going to worry about it. All right. So, all right. So, defined implicitly, some stuff that you've seen defined implicitly before. What is this? What's this an equation of? That's a circle, right?
After you subtract x squared over, and you square root that jump, and then there's no more squares.
Then it would be defined implicitly. Yes, sometimes you can go back and forth between the two.
No, I make sure that it's as explicit as possible.
Okay. Okay. All right. Good to know. There are. Okay. All right. So, some other stuff you've seen, we did like hyperbolas might look something like this: x plus 1 squared over 25 minus y minus 3 squared over 16 equals 1. Pre-cal. You don't necessarily have to remember a lot from pre-cal for this. Other equations that might be defined implicitly might look something like something we've never seen before. X squared y minus 3y equals x plus 2. Okay, so it might look like crazy stuff we've never seen before, but the x's and y's are all mixed together. Some of these are going to be like difficult. Like if I put a square right here, you're not even going to be able to solve that for y. Right? So it can't be solved for y. So you have to deal with it implicitly, and you cannot make it an explicit equation. So that's Thomas's philosophy. Okay, so whenever we have been taking derivatives so far, we have been doing derivatives somewhat implicitly. I just haven't told you that you were. So like when we took the derivative of this, the derivative of 3x squared is 6x. And what did we write over here on the left-hand side? Either y prime or dy over dx. And so some of you, I have definitely written in notes, but some of you may have chosen to do y prime, which is fine. But you, I'm sure, just put an equal sign and put 6x. Yeah. But you must put this now. So this means the derivative of y with respect to x. No, not necessarily. So what we're doing is we're taking the derivative with respect to x. So whenever you type this into your calculator, Noah, when you type a derivative into your calculator, what do you have to put? Like you'll do differentiate, you'll type in the equation, then what have you got to do? You got to do comma x, right? Because you're telling it you're taking the derivative with respect to x. It is possible to take the derivative with respect to other. Yes, you could take it with respect to y, or even a variable that's not in the equation, like t, which we are actually going to do when we do related rates, but that's a little ways away, so we won't worry about it right now. But so far, everything's been with respect to x. So we have not been writing this, but I could put the derivative of x with respect to x over here next to this. But this equals 1, right? So we haven't been writing it. You won't. Well, you won't. I did just to say that we could have. To tell you that we've been doing that, we just haven't been writing it because it's unnecessary. Yes. Yes. Okay, so. Okay, so if we are taking, what we're going to be doing now is going to be different. Okay, we're going to be taking a derivative with respect to x. So when I see this right here, this means take the derivative with respect to x. Now the problem is we've seen that a lot. We've seen d over dx a lot. It's just, I basically told you it just means take the derivative of this stuff, and we haven't thought about anything except for it just means to take the derivative. But the difference this time is that this is an x, but our equation has a y. So when we're taking the derivative, of this, we're going to take the derivative just like we would if it was an x. It's going to be 6y to the first power, which we don't have to write. But we must multiply it by dy over dx. So this is a y. It's not the derivative of y. This is the derivative of y with respect to x that you're multiplying it by. It's technically like a chain rule, like y because it's not an x. 6y times dy dx. Because dy dx has to be there.
Yeah. Okay. I don't know. So normally we have an equation say y equals dx squared.
Uh-huh.
And when you would write it as like dy over dx of dx squared. So what does it mean? Like we don't normally write.
So what you're doing,
equation in there.
right? Because
we're assuming that I need a big x.
Right. So yeah. So like this y turned into dy dx. What's the derivative of just y? It would be 1, right? But then you have to multiply it by the derivative of y with respect to x, which is the dy dx. So 1 times dy dx is dy dx.
Yeah. Oh, because you have to take the derivative of y, which is just 1. So
right.
It doesn't normally matter.
Right. It normally does not matter. But if we have something else with the y, then we'll have to do this. So this is not overly complicated. Yes. We are getting way too caught up in the notation. Let's move on and look at what it looks like in a problem. Okay? So, we are, yes, going to see it again, but yeah. But there's a really simple rule of what you're going to do that I think you guys will be fine with. Okay? No, it's not 6y. All right, so basically what you need to know is if you take a derivative of something with a y, and you're taking that derivative with respect to x, which right now we're pretty much always going to be doing, you have to put dy dx with it. So, when I take the derivative of x squared here, derivative of x squared is 2x. Because it is an x, and I'm taking the derivative with respect to x, I don't have to put anything extra here with it. I could, if I wanted, put dx over dx, but that would just be 1, so it's unnecessary to put it there. But if I take the derivative of 3y, what's the derivative of 3y? 3. And because this is a y, and I'm taking the derivative with respect to x, I have to put dy over dx next to it. This is saying take the derivative with respect to x. So x is your variable you're taking the derivative of. So anything not an x is going to have the dy dx with it.
It's stating that it's the derivative of the y. Oh. So you're basically saying like we were the one that
yeah. It's the derivative of the y.
It's stating that. Just do it next. It's just saying.
Just do it.
It's just saying.
Okay. Let's keep going because you're getting caught up in the meaning a little too much, I think. Yeah, yeah, this would be your answer. Okay, you'll catch on. We gotta keep going. We gotta keep going. I promise it's not as bad. Students usually do good on this part. We're doing like we did on that one time that whatever, I can't even remember what it was I taught now, but oh my, it was a bad day. Okay, so let's keep moving, and I think you're gonna pick up on it once we get to the next problems. So if I want to take the derivative of this, I've got an x squared and a y to the third, and they're multiplied together. What do I have to use to take that derivative? Product rule. So, all right, so it's going to be x squared times the derivative of y to the third. What is the derivative of y to the third? 3y squared. And because that was a y, I have to put dy dx with it. Plus, yes, plus y cubed. And I did not take the derivative there, right? That was just y cubed. I did not take a derivative, so I don't put a dy dx, times the derivative of x squared, which is 2x. Since that is an x, it is unnecessary to put dx there because that would just be 1. So this is our answer. They will probably clean it up a little bit and write this as 3x squared y squared dy dx plus 2xy cubed. Emerson, you're back. Daniel, you've said something mean to every person in this classroom today.
That's a personal achievement for him.
Okay, we are just taking notes on. You have not missed too much yet. Okay. All right, so this is the type of problem you're going to see. Those are just warming up. So, copy down this problem. You can do this is not too awful much different. All right, so we're going to start with implicitly defined equations this time. So the first two, I was just showing you how to take that derivative with respect to x. They weren't equations. So we got y to the third plus y squared minus 5y minus x squared equals -4. It just does. What's, like if we wanted to, and I do because sometimes these are so cool. If I pull up Desmos over here, this is the great thing about Desmos that you don't get to use on your test. So this is the graph we're talking about right here. So
that's differentiable, right?
All right, so this, no, this is differentiable. No, it does not. This is not a function. It is not a function, and that's why it has to be defined implicitly. You can't define it explicitly because it's not a function. Explicits have to be functions. And the implicit might be a function, but it doesn't have to be a function. All right, so the first thing we're going to do is take derivatives of both sides with respect to x. So the derivative of y to the third is going to be 3y squared. Because that had a y, I put the dy dx with it. Plus the derivative of y squared is 2y. What does it need? dy dx. Minus 5. This needs a dy dx. Even though the y went away, it was still, we took the derivative of something that had a y, so it still has to be there. And then minus 2x, this does not need a dy dx because it wasn't a y. What's the derivative of -4? 0.
So it's basically like
Yes, if you're taking the derivative of something with a y, put the dy dx on the end of it. Okay, so what we want to do next, we're trying to find the derivative, which is our dy dx, right? So we want to get the dy dx by itself. So the first thing we're going to do is we're going to move all the dy dx terms to the left and all the other terms to the right. So the 2x is the only thing that needs to move over here. So we got 3y squared dy dx plus 2y dy dx. It doesn't, but typically I try to put my dy dx on the left. Just because you are more likely to get like the same signs as what they're going to have on answers if you move everything to the left instead of having things like backwards. I mean, it can still be correct doing it either way, but if you're someone who does not like to follow the rules and suggestions of society and you want to put it on the right to be a rebel, you can. Just be careful. All right, so anybody have an idea of what we should do next? We can factor out the dy dx because every term on the left has the dy dx. Okay, so that's the next step. Factor out the dy dx. And so, since we factored that out, this is dy dx times all of this stuff. How could I get the dy dx by itself? Divide by all that stuff, right? So I'm dividing by 3y squared plus 2y minus 5. And so my derivative of y with respect to x is 2x over 3y squared plus 2y minus 5. Is the derivative of y with respect to x.
Does that mean, is this the one we always get, or the new one?
I mean, it's the one we always get, but what's different about this than what we've done so far? It's got y's in your derivative, which is okay.
What happened between 3 and 4?
We just divided both sides by what was over here in this parentheses. And then, so it cancels over here, and then you just have this expression on the right.
Yeah, but like, that's what you need to do since it doesn't have the vertical line. Okay, yeah.
You would have to, if you want to know the,
The derivative is the slope of the point.
yeah, so like, let's go back over here, Desmos.
At the thing, bro.
Let's say,
Thomas understood.
let's say,
How can you?
like the point 1's on this graph, right? So if I want to know,
Then how do you know the why? You asked me a question.
You mean the understood one?
so you can find, like, it depends on the problem, but without going into too much detail, like, let's say they'd have to give you a y value here. If they gave you, they say y equals 4, you could plug 4 into this original equation and find the x that goes with it, which is, and then you could plug both x and y into your derivative, which will give you slope of your tangent line, and then you could write your equation of your tangent line. But that goes further than we have to on this.
So what did you just say? I wasn't paying attention.
So if, like, let's say they asked us for the equation of a tangent line on this problem. Equation of a tangent line, just like always, requires 3 things: a slope, a point, and then a equation of the tangent line, right?
You need to plug the whole freaking point.
So, like, they would have to give you an x or a y coordinate. In this case, like, they'd have to give you a y coordinate, because if they give you x, you can't solve for it. But if they gave you a y, they said maybe y equals 4 is the point where you're looking for this. You'd plug 4 into the original equation and solve for x. You might even get 2 answers for the x. There might be 2 points where the y equals 4. And then you could take those numbers and plug them into the derivative to get the slope. And then you could write the equation of your tangent line. Yeah. So, like, for example, if you said y equals 4 at, like, this point right here, and over here, so there would be 2 places where you'd have to have a tangent line. You'd have to have 2 different tangent lines there. But we'll get into that.
Yeah, so now it's really you have like a split, a sort of every whole point.
Yeah.
For this one, let's just square both sides.
You cannot do that because of that plus sign. It does.
Take the root of both of them.
Okay. So, here we go for this one. Okay, we're asked to find dy dx. So we're going to take the derivative of both sides. What's the derivative of x squared?
2x.
Noah, get off that phone. And tell me what the derivative of y squared is going to be.
2y what? Oh, dx. No, nope.
There we go.
It's dy over dx, not dx.
And Logan, what's the derivative of 36?
Oh, it's 0.
0? Good. Alright. So in this case, we're trying to get that dy by itself. We need to move the 2x over, so we got 2y dy dx is going to equal negative 2x. And what's my last step here? Divide by 2y. So dy over dx. The 2's actually cancel, so you just get negative x over y.
That's ugly. I hate it. It's tough. I understand it.
Okay.
Do we have to multiply that?
No, you do not. You could, but you don't have to. You are going to have to use chain rule on this. So, chain rule, product rule, quotient rule, all of those things still possibly might apply.
Why can't we just take one?
So you could multiply this out, but it's going to be a little harder to solve if you do that. So I would just use chain rule here. So we got x minus 4 squared plus y minus 3 squared equals 100. So to take the derivative of x minus 4 squared, 2 x minus 4 to the first power times the derivative of x minus 4, which is just 1. You don't have to write that if you want. Plus 2 times y minus 3 squared, and y minus 3 to the first power. You could go ahead and distribute if you want. And times the derivative of y minus 3, what is that? dy dx, since it has a y with it. And derivative of 100, 0. So we could distribute here. We got 2x minus 8 plus, now what you got to be careful of here, we got 2y minus 3, but that dy dx, I'm sorry, 6 there, dx, it also has to be distributed there.
You can't subtract 6 from negative 8.
No, you cannot combine them because these have dy dx's. So 2x minus 8 plus 2y dy dx minus 6 dy dx equals 0. Yep, the 2x and the 8 are going to go to the other side, so we got 2y dy dx minus 6 dy dx equals, I'm going to put that positive 8 first and the negative 2x second, but you could do negative 2x plus 8.
Wait, why are there two?
You may have already factored out. Guess you could. Instead of distributing it, you could. Yeah, you could have done that. You don't have to distribute it. You're right about that. But you do have to have parentheses. It's not just with the 6. But yeah, we could have done that. That would have been a little quicker. And then, last step, we divide by the 2y minus 6. So dy dx equals 8 minus 2x over 2y minus 6. And they probably will, because every single number there is divisible by 2, they'll probably reduce it to 4 minus x over y minus 3. That you can only do that if every number is divisible there. I like these two.
They're algebra. Wait, no, it's not.
It is calculus with some algebra.
Literally, like, Jack, I don't have the same thing. At least we got numbers back.
Okay. Questions?
No, chill. Let's go ahead.
Okay.
What? What's the what? Never mind, let's not.
Where is square root from?
Check my mind.
Alright. Alright.
Yeah. Typical note taking, bro.
Okay, so we're looking for the slope of the line, tangent to x squared plus 3y squared equals 10 at 1 square root of 3. So, if it's asking me for slope of the tangent line, what should I do? Derivative, and in this case, that's my dy dx, right? So, Ethan, tell me what to do to take this derivative.
Since the first one's an x, you just do 2x, and then the next one's a y, so you take the derivative, it'd be a 6y, and then dy dx, and then equals 10, and it's just 0.
Good. All right, keep going.
And then from there, since it's asking for the line tangent, you need to do. Oh wait. Oh, you find the derivative. Okay. So you take the dy. No. You take 2x. You set it equal to 2x. 6y dy dx equals 2x.
Almost. When you move that 2x to the other side,
Negative 2x.
negative 2x. Okay?
You don't need to factor out the dy dx.
Not in this case because you only got one term, yeah.
It would just be divide 6y and then dy dx equals negative 2x over 6y. And then that's just your derivative. So
Right.
you can just-
I would reduce it to negative x over 3y, but you don't have to.
So when you're like finding the slope of the point, how do you? What's the notation like?
All right, so notation, that's a good question. Because you can't do like f prime of x because you got two numbers. So notation for this is going to look like this. dy dx such that, this line right here means such that, xy equals 1 square root of 3. So this is saying dy dx such that I'm plugging in 1 square root of 3 for xy is going to equal, and then you can just plug in the number. So
Handle f of x, I literally can't.
sorry about that.
Wait, why do you write it below the line? Like, why is it
I don't know why they wrote it like that, but they do.
I'm gonna forget everything.
That's your line. That's your slope. That's the answer.
Yep.
Leave it like that, right?
Yeah, you don't have to rationalize or anything here, although you could, and it is going to simplify a little bit if you do. But, you know,
So is that whole thing?
for response, leave it like it is.
Or is it just a fraction? That isn't too hard.
This is your slope of the tangent line at 1 square root of 3. And this one only asks for slope. It doesn't ask for the equation, so you can stop here. No, I'm gonna make you come put that phone on my desk.
No, it has a 3.
Okay, here's another one. Alright.
I gotta start a new piece of paper. What the frick? Oh, okay, I get that. I already have it. Oh, yeah. I spaced my parts like I read it.
What? 3 parentheses x squared plus y squared. Close those parentheses and square that on the outside. Yeah. Equals 100 xy.
Oh my god.
On one side and a product rule on the other side.
How do I find the
Okay. Okay. Tell us what to do, Thomas.
Throw a 6 in front of that because it's 2 times 3. And we're going to get, let's have the parentheses x squared plus y squared. Yeah, then we're going to, hold on. You got it. No, it just stays because it subtracts 1, correct?
Right. So you can put a 1 there, but you don't have to.
Yeah. And then it's going to be times 2x plus
did it, Tom.
Perfect.
Wow.
Good job. Okay, so
Now I gotta write all that down.
now, what do we got to do?
You could simplify everything.
Well, move all of the dydx expressions to the left.
Can I move stuff on this left side yet? Because this stuff is multiplied together. So I need to distribute over here first. I'm going to just keep my 6 out front first, but you could distribute it. So I'm going to have 2x to the third plus 2x squared y dy dx plus 2xy squared plus 2y cubed dy dx. And that's going to equal 100x dy dx plus 100y. And then that 6 can be distributed to everything, so all those 2's turn to 12's. I just didn't move anything. I was just distributing the 6, but if you wanted to go ahead and do that in that step, you could have. So I'm going to. So everything with the dy dx needs to be on the left. Everything on without the dy dx needs to be on the right. Is it okay with you guys if I go ahead and factor out the dy dx as I do this? So Thomas says I can, so I'm going to. So you got a dy dx here, so you got the 12x squared y. You have a dy dx here, so you got plus 2y cubed. And then you've got this. Oh, it should be a 12. Sorry, I read that wrong. And then I got the 100x, but it's got to move over to the other side, so it's going to be minus 100x. Equals, then I got the 100y that stays here, and I'll have a minus 12x cubed and a minus 12xy squared.
So you can factor out the plus and equal sign.
Technically, no, but I kind of like did that step in my head because where I had this 100x, I made it a negative 100x, like I had already moved it to the other side, yeah. So I did that part in my head to just make this a little shorter, but you'll have to make sure you change signs if it moves. No, it would be okay to do this on FRQ, I'm pretty sure. I don't think they come. Mm-hmm.
So then you divide.
Mm-hmm.
12x squared y plus, yeah. And the other side gives you dy dx. And then to find the slope of our equation at the point 3, 1, you need to do dy dx and then x, or like a line. You gotta do a line, right?
Let me write this part first. Actually, and since we got to plug a number into this, 112 are divisible by 4. 2 will work, but 4 is bigger. So let's go ahead and just reduce this. So that'd be 25y minus 4x cubed. No, we're dividing by 4. It's going to be 3. All right. 3x cubed minus 3xy squared over 3x squared y plus 3y cubed minus 100.
Minus 20.
I'm sorry, oh, 25. Yeah, when you move these pieces over, Chandler, they have to become negative.
So now since you got your dy over dx, you can do dy over dx line x and y in the coordinate, and then on the next one you can do, was it 1 negative 3?
I forgot. 3, 1.
3, 1. So 3, 1 and then just plug that.
And so we'll have 25 times 1 minus 3 times 3 cubed minus 3 times. Oh. Yes, please.
When you put at the bottom, is it x comma y equals?
Wait,
Yeah, x comma y equals 3 comma 1.
Miss Hyatt, you mixed it up. It's 3.
I did, didn't I?
3.
Oh.
That would have made a difference too.
Yes, it would. Because of that square.
Yeah. I was thinking,
All right.
I was about to say it might not be that way.
It's like some stuff right here, it's big long division.
We're gonna make it solve it. Oh,
Yeah, I know. I forgot to do regular addition. I can do it.
All right.
Add 98.
So, just to prove we can. Let's see. This is 3 to the 4th, which is 81.
Oh, wait. Yeah, 3 plus 27. 27 times 3.
Minus 9 over 27 plus 3 minus 75. So, put those together, it's going to be 25 minus 90 over 30 minus 75. It's going to be negative 65 over negative 45. And if we reduce, they can divide by 5, so it'll be 13 over, yeah.
I enjoy that.
All right, there we go. Okay, so,
That was disgusting. Oh.
yeah, you could take this stuff right here and set it equal to that. Or if you just have like a string of equal signs, the way I have it here, as long as you've clearly shown what that is at the beginning, that's fine too. All right, so let's see. That was the last one.
That's enough.
And the assignment is going to be, let's see.
No, Mom.
Oh, wait.
No, Mom.
No, it's,
If there's more than 5 questions that people like for that last one, I'm like,
most of them are quicker like the first ones that we did.
and
Thomas,
30 short ones.
you're going to have to quit.
Just give us like 5. I'm begging. Just 5.
All right. Okay. Page 179. 1 through 19 odd, 41 and 43. Some of them, it's like 12 problems. Some of them are going to be much quicker, like the first ones that we were doing there. Some of them will be a little bit longer. I'm not sure. I think they might be tangent lines, the reason they're separate. Tomorrow I will not be here because I'm going to do an AP Calculus training online, which hopefully will be good because usually they are helpful. But I've never done one online. I don't like online stuff. It's Miss Hendrick.
Ask them about
Yeah.
how they should teach me.
Huh?
Ask them about how they should teach me.
Ask the sub. What? Oh, how can I help Thomas McComb? Yeah. If Miss Hendrick is available, I usually have her because while she cannot do calculus, she can do Math 1 and pre-calculus, so she can help students. I do like Mr. Bray. He's so nice.